Hey everyone, today Vince, Niv and myself Wilson will be presenting a video about Introduction to Rates of Change. Now what is rates of change? Rates of change is basically a change of one variable relative to another. When you graph out rates of change, the independent variables will be on the x-axis and the dependent variables will be on the y-axis.
Three fundamental concepts of functions: existence of limits, continuity, and differentiability. Limit fx exists when left side limit exists, right side limit exists, and both sides are equal. For a function to be continuous, f of a has to be defined, limit f of x as x approaches a exists, and both sides has to be equal. We just learned about continuities. What about discontinuities? There are three types of discontinuities: removable, jump, and infinity. Differentiability. A function f of x is differentiable at f equals to a if this limit exists. So, when is a function not differentiable? A function is not differentiable when there is a vertical tangent, there are sharp corners, and when there is a discontinuity.
Why do we want to differentiate? Well, we basically differentiate so that we can find the derivative and hence find the rate of change. Well, there are a few methods to differentiate. One of them is the constant rule, which looks a little bit like this. And then there's the sum rule. Let's take the function fx as an example. Fx equals to x cubed plus 5. The derivatives for x cubed would be 3x to the power of 3 minus 1, while the derivative of 5 is 0. Hence, we get 3x squared. Next up is the product rule, which looks something like this. Let's use this equation as an example. First, find the derivatives of u and v. Then, substitute them to the formula which was shown previously. We will finally come up with this for the derivative when simplified. The next method will be the chain rule. There's a few ways to do it, so we'll explain it using the most efficient one. For this example, let's first differentiate the things inside the bracket. Then, we bring down the power of 3 to the front and minus 1 of it. Next, we bring down the 10x that we differentiated before. We will end up with this when everything is simplified.
Applications in motion. Differentiation is applicable to almost all qualitative values. For example, in physics, the derivative values of displacement with respect to time gives velocity, which we will look into in the following slides. Of displacement. Instantaneous velocity is the rate of change of displacement, where s is equal to f of t, which is displacement or position, and v is equal to ds over dt, which is the first derivative of displacement. Acceleration is the second derivative of displacement and the first derivative of velocity. Of velocity. Instantaneous acceleration is the limit of average acceleration as the time interval approaches 0, or the rate of change of velocity is the acceleration. That is, the acceleration is a derivative of velocity. The displacement covered by a car is given by the following equation. We must determine the acceleration of the object when the velocity is 0. We find the derivative of s with respect to t, which gives us the velocity. We then set v equal to 0 and then solve the equation for t, and then find two values of t. We then find the acceleration, which is given by the second derivative of displacement, which gives us an equation st minus 8. We then substitute the value of t, which is the positive value because time cannot be negative. We then get a value of 10 meters per second square.
Alright everyone, that's the end of the video. Thanks for watching and see you next time.